Might as well get started. So thank you for joining us today. We're doing our HPC workshop number 2. This one is going to cover the topics of storage and software. So thanks for those of us who are here in person, and thanks to those of us who are here on Zoom. This meeting is being recorded, so we'll post it to our YouTube channel just like the other ones as soon as it's ready to go. But let's get into the workshop for today. So last week we covered the basics of what HPC is and how to access it. And this week we are going to get into the topics of storage and software. You can see our full list of topics in our documentation on the calendar. So next week we will get more into the details of running jobs. So if that's something you're interested in, please join us next week for that topic as well. And today we're going to cover the storage resources and software. Just for those on the Zoom, just to let you know, please keep your microphones off. The sound does come through in the room here. So if you do have a question, please type it out in the chat. That would be the best way to do it. We have people monitoring the chat. So if you post it in there, they'll read it out to me and we'll do it that way. So thank you. So let's get into it. So here's our outline for today. We're going to do a little overview, talk about storage, talk about transfer methods, how to get your data on and off of the HPC. And lastly, we'll cover software. So an overview of the module system and how to install your own personal software. And unfortunately, my little remote thingy isn't working today, so I'll have to stand over here behind the PC. Hopefully that's not too much of an issue, but yeah, let's get into it. So first topic is data storage. So just to give some terminology here, computer terminology, some of you may be familiar with this, some of you may not, but this is just to make sure we're all on the same page with the words that we're using. So memory versus storage when it comes to computers, and this is sort of just general terminology. This doesn't necessarily apply just to HPC, it applies to any type of computer. So there are two main types of storage or data storage, right? Like you can have, when you're saving your data, there's two sort of functions that it has. The first function that we talk about is memory. This is also called random access memory or short-term memory. When you have your laptop, you might have 8 gigabytes of RAM, you might have 16 gigabytes of RAM. This, in a sort of very generic colloquial sense, can tell you how fast your computer is or how many different programs you can have open at the same time. So if your laptop has a very small amount of RAM, you might find that if you have, say, Photoshop and Google Chrome open at the same time, then your computer slows down substantially. But if you have a large amount of RAM, then you can do more work. This is the amount of data that it can store in its short-term memory, so the amount of stuff that it can sort of do simultaneously in a way. And this type of memory is very fast, it's very close to the CPU physically, and it stores the data and instructions for whatever current program is running, whether it's on your laptop and it's a browser, or whether it's on the HPC and it's some code that you're running. And this type of memory is volatile, it's not permanent memory. So if something is stored in RAM, when you turn off your computer or when your session on the HPC finishes, this data is erased after it's used. So it's only saved during its usage. In contrast, we have storage. This is what we typically think of when we're talking about hard drives. So it might be an older disk drive like the one you see in the picture here, or it might be a newer, sorry guys, just gotta, please keep yourself muted. Thank you very much. Hard drives, right? When we're talking about storage, this could be older types of hard drives like these spinning disks, or it could be newer types of hard drives like NVMe flash storage. So there's all different types, but the purpose of these drives is to store long-term data. So this is data that when you are not actively using it, it stays there. So the storage is persistent, right? When I'm not actively reading a PDF on my folder, if I close it, it still stays on my computer, right? So this is the main difference between storage and memory. The storage on your computer just tells you the total amount of data that you can have on your computer. It doesn't necessarily tell you how many different programs you can have open at the same time or anything like that. So it doesn't necessarily affect the performance directly of any particular program that you're running. Storage also is slower to read and write than RAM, generally speaking. It stores programs, data, whatever, you're in charge of what goes in your storage, so you can choose what goes there. This is whenever you're browsing through your computer, clicking on folders and things, this is the storage that we're talking about. So this is just to sort of get this out of the way, make it clear what we're talking about, memory versus storage. Yes, question?
When you talk about hard drives, you include things like thumb drives and all those little
sure, yeah, that can,
devices.
yeah, anything with persistent storage, right? Anything where if I'm not actively using it, the data doesn't disappear, right? So if I put a PDF on a thumb drive and then plug it into another computer, it would sort of defeat the purpose of the thumb drive if the PDF were to disappear, right? So persistent storage is the main feature of storage versus memory, which is volatile, right? Okay. So just to continue on this, we have memory, which determines how much data a running program can hold at once. If the memory runs out, then the program will terminate with an out of memory error. A lot of programs on your laptop do memory management on their own, so it's very rare that you'll get an out of memory error on your laptop if you're just doing things like opening a browser, things like this. And again, that memory is wiped when the computer shuts down. So anything that you had in RAM previously when you shut down your computer will be gone when you boot it up again. You can think of, say, if you're working on a Word document and you haven't saved it to the disk, there's still a version of that that's in your memory, but then when your computer shuts down, if you haven't saved it, it goes away. And then storage again determines how much total data can be saved to the computer. And that storage remains intact when the computer shuts down. So let's review a little bit. Why does this not go away? I don't know how to make that go. Okay, now it's gone. Sure. Anyway, the HPC system, let's review this a little bit real quick. So we have all sorts of different node types. We covered this last week. The main node types to be aware of are the login node, the compute nodes, right? These are the ones that you're probably going to be using the most. Today, we'll also talk a little bit about the file transfer node when you're moving data from either an external server or from your local laptop onto the HPC. And pay attention to the connections on this picture because the login node has access to our shared data storage. So that's what we're going to be talking about next, is what this shared data storage is actually composed of and the different shares that users have access to on the shared data storage. So here's a review of the nodes real quick. So we have the Bastion host. Remember, this has no compute, no storage. It's effectively just a security feature. It's not intended to be used really for anything at all by the users. The login nodes don't have compute. You can perform minor operations such as editing files and things like this. But if you have to compile something or if you want to run your code, the login node is not the place to do it. The login nodes do have access to the storage. So the main purpose of the login nodes is for your file management and for your job submission. The compute nodes, this is where the majority of the compute is done. So yes, they do have access to compute and they also have access to the same storage system as the file transfer node. And these are used for running your code and compiling software and anything else that requires more than minimal CPU effort. And lastly, the file transfer node, no compute on this, not intended to be, code is not intended to be run on this node, but it does have access to higher transfer speeds than the login node. So if you are moving a large amount of data onto or off of the HPC, this is where you would want to do it. It also has access to the rental file system, which you don't see here on this image. Yes, question?
Yeah, so just to connect back to what you talked about last week. So when I see the command line shows Puma, am I at the login nodes or the compute nodes?
Yeah, so the question was when you're on the terminal and you're logged in to the HPC and it shows Puma, does this mean that which node does this mean you're on? So if you look at I wish I could pull up a terminal on this, but I'm on the library computer here. When you look at your terminal, there's a few different things to pay attention to. If you look at it, there's going to be something in parentheses on the left-hand side. This will be the cluster name. So this is the job submission host. So this is not the node that you're on, but this is which cluster any particular job that you would like to run gets submitted to. So you can change that by typing the name of which cluster you want, and then you'll see the word in parentheses changed to whatever you just typed. So if I'm on Puma and I wanted to submit to Ocelote, I would just type Ocelote, then you see that word in parentheses change, and that's the job submission host. That's referring to which set of compute nodes you're accessing when you're running a job. If you want to know which of the other types of nodes you're on, you would look at your prompt. And your prompt, when you're on the terminal, looks like your username, an @ symbol, followed by some other name. And that name that comes after the @ symbol is the name of the node that you're currently on. So when we talked about the login node last week, we mentioned that the names of the login nodes are Wenteltrap and Genonia. So if you are logged onto the HPC, and all of this information is in our documentation as well. So if you want to refer back to any of this, please refer to our documentation. It is available, easily accessible, hpcdocs.hpc.arizona.edu. Yeah, another question?
Yeah, so I guess a follow-up is that if I want to install software, should I SSH into the terminal and do it there, or should I open an interactive interface? Because I think when I open an interactive interface, I feel sure that I'm on a computer node that way. I'm not sure if it's for security or what way would you recommend?
So we'll cover installing personal software later in this presentation. So we'll get to that.
Sure.
Yeah. So those are the different node types. So yeah, let's continue on. So all node types except for the bastion host or gatekeeper, as it's also known, have access to the HPC file system. So whether you're on a login node, compute node, or a file transfer node, you should have access to the main HPC file system. If you do not have access to the main HPC file system, you are not on one of those nodes. So the data transfer nodes or the file transfer nodes also have access to rental. So memory versus storage on the HPC, right? So we talked about the difference between these terms just a minute ago, but now we're going to talk about them in the context of the HPC, right? So when you're running a job on the HPC, memory is determined by the number of CPUs that you've requested by that job. So on Puma, for example, you have 5 gigabytes of memory available per CPU. And we'll get into more detail on this next week when we talk about running jobs. So don't worry if it doesn't fully make sense yet. When we're talking about the running jobs, we'll get into exactly how to do this and what this all means. But the memory is determined by the number of CPUs. So one CPU gives you 5 gigabytes of memory, 2 CPUs gives you 10 gigabytes of memory on a particular job. That's how that works. And the storage is determined by which active working directory are you on. So there's a few different shares that we have in the main HPC file system, and we'll talk about those in just a moment. And when you're thinking about the different shares on the HPC, effectively what you can imagine is just you have different hard drives, right? I've plugged 5 different hard drives into my computer, and each of them has a different amount of storage. One might have a terabyte of storage, and one might just have a few gigabytes of storage, right? So when you're going through different folders, think about moving through different physical hard drives. And if you'd like to refer to these links, there are some links there on the slides for our documentation. I tried to include those wherever relevant. So hopefully you find those useful. So now we'll talk about all of the different shares that are on the HPC file system. So our high performance storage. This is mounted directly on the HPC file system, meaning that it's much faster than other types of storage because it's so easily accessible to the HPC. The 3 shares that are available under the high performance storage are home. So every single user gets a directory under home / some number / your username. So, and this directory gets 50 gigabytes. So you can think of that as one hard drive that has 50 gigabytes available to you. If you fill that up, you've filled up the hard drive and you need to go delete other stuff in order to make more space. That's not a flexible thing. Each PI, so each faculty member or manager of a group, right, gets the group's share. So /groups, this is 500 gigabytes of persistent storage. And this is shared between all of the members of their group. So we talked about groups and managing groups last week. So this is, you know, if I join a research lab, that PI has their group share 500 gigabytes and I'm sharing that. So it's just like one hard drive that I'm sharing between myself and my other group members. Yes, question.
And this one is additional to the 50 GB that
Yes.
we have.
Yeah, these are all
The additional one.
You have access to all of these.
Okay.
Yeah. So if you are a PI, you get your own groups. If you're not a PI, you join a PI's group and then join their shared groups folder, right? And then the third main share on the HPC high performance storage is called XDisk, or also sometimes called project space. This is a temporary allocation. So home and groups are permanent while XDisk is temporary. 300 days is the time limit for an XDisk, and you can request up to 20 terabytes. All of these are free. And as soon as an XDisk share expires, so say I create it, I wait 300 days, it expires, I can open up a new one immediately. So there's no limit on, you know, you should always have access to XDisk, but it does expire, meaning that data needs to be moved off of it every 300 days. And you have up to 20 terabytes there. So this is for active projects. This is why the expiration happens, is because it's not intended as long-term archival storage, it's intended for active projects. Rental storage, on the other hand, this, first of all, is not free. So it does incur a cost at a rate of around $50 per terabyte per year. I don't have the exact figure, that's approximate. So PIs can purchase storage in the rental share. This is not mounted on the HPC, so it is not accessible to the compute nodes. So if we go back to that image that we saw previously here, this is not the shared data storage. The rental storage server is off to the side somewhere, and it is not connected to the compute nodes. So if you're trying to run a job and you have some data that you want to analyze on rental, that needs to be first moved on to the main HPC storage in order to be accessible by the compute nodes. So it is mounted to the file transfer node. So if you want to do that transfer, you would access the file transfer node and then copy the data from rental onto whichever one of those that you choose.
And for example, if someone does not take data from the X disk, so after 300 days, it will be just deleted from that. Okay, so you will not have any access to that.
So we have a snapshot system, so you have a few days to try to recover that. But generally speaking, once the X disk expires, the data is deleted. And don't worry, there are plenty of emails that go out in advance. It's not just, we don't surprise you with it. We warn you there's plenty of emails that go out in advance of that to remind you. Yes.
Can you tell us a little bit more about a snapshot service?
So it's sort of like a checkpointing system. It's not exactly a backup. It effectively means there's a 5-day window, and each of those 5 days takes a snapshot of the file system at that period in time. And that snapshot can be restored effectively. But once 5 days is gone, the snapshot is not available anymore. So it's not a backup. It is not the same thing as a backup.
So
it's a checkpoint.
So we always still need to plan our data transfer plan at the end.
So if you have very important data, we highly recommend that you have some other service that backs it up elsewhere, because we do not offer backup services, right? If you make a mistake and you're like, you know, delete some file and you tell us quickly, we might be able to restore that for you. But generally speaking, full directories, and especially if like an X disk gets deleted, we don't offer that backup service, right? So we do have other options. So for example, the rental storage, this is persistent. This doesn't get deleted automatically. Again, not backed up itself, but it is for example, if I have important data in my groups and I want to create a copy of it, I could put a copy of it on rental and then I have 2 copies of it, right? But we definitely recommend for security in order to make sure you maintain your data integrity that you have some other service to maintain backups. So just to continue with all of our different storage resources, so we can cover all of the bases here. One additional storage option is something called RDAS, which stands for Research Desktop Attached Storage. And PIs can request up to 5 terabytes. This is not HPC storage. This is explicitly for mounting a remote share to a workstation or to a laptop. Right, so this is a shared, you can imagine it as some hard drive with 5 terabytes on it that every group member can access remotely. And it can be copied to the HPC just like anything, but it is not explicitly HPC storage. It's not mounted on the HPC. It is not accessible to any of the nodes by default, right? Just like any other type of data storage, it can be copied there, but it is not explicitly mounted there. So it can be copied. And our last service is, we call it Tier 2 or AWS. So Amazon Web Services offers archival data storage. And we have more information about this in our documentation. This is a good option for long-term backup or archival data. So it can be copied to the HPC, but if you have, it can incur costs when you pull data out of the archive. So this is not intended for active project data, but instead for data that has been analyzed and maybe publication has been accepted and everything is finished. So this is a project that has been completed to an extent and you're archiving it for later. It's not necessarily intended for active projects. So these are the 4 main storage resources that we offer. Just also, there is a pricing model for AWS. There are some free options and some paid options, so just be aware of that as well. So the main HPC high performance storage is with something called a cumulo storage array. This houses each of the shares, home, groups, and X disk. And this is the one big storage array that houses all of it. And you can see here, this is about the storage usage that we have as of relatively recently. So the total capacity is about 2.5 petabytes, and we usually hover at around 80% capacity. And this is because we have this policy of rotating data out through the X disk. This is why it's intended to be active project management, because this is a high-speed flash array. So it's all flash, 2.5 petabytes of flash storage mounted to the HPC. So it's very fast, very high performance storage. So this is why it's not really intended for archival storage because of its high performance capabilities.
We have a question from chat. So for RDAS, does remotely mounted mean there is no physical thing attached to team members' workstations or laptops?
That's correct. There is no physical object. This is a server that we have in the data center. And we have instructions on how to mount that in our documentation. So if you go look at our storage and transfers page and you find the RDAS entry, there will be instructions on how to remotely mount that share. It involves accessing a VPN and doing a few configuration steps on your local workstation in order to get that to appear. But once it is mounted, it'll look just like you have a hard drive plugged into your computer. Again, it's not actually one of those. It just behaves like one of those. Okay, yeah, so this is our cumulo storage array, again, intended for active project data. So let's talk a little bit more about each of these directories. The home gets 50 gigabytes of space allocated to each user. So here's an example of where you would find that. This is my home directory, home slash, you have a U and some number. It's different for each person, and then your net ID. And this will be the default directory that you go to when you log on to the HPC. Please be aware of the storage usage of each of these shares. Because if you do fill up your home, if you get to 50 gigabytes out of 50 gigabytes of storage, this can cause login problems. So don't fill up your home directory. Be aware of the data usage. We have, if you go on Open On Demand, or there are some commands that we'll discuss shortly that allow you to view your disk space usage. So yeah, just be aware. Yes, question.
When you say don't fill it up, how close can you get?
I would say give yourself at least a gigabyte.
How much?
1 gigabyte.
1 gigabyte?
So get to 49, and once you get to 49, start clearing stuff out. That would be my personal recommendation. It might be possible to go over that slightly, but just to maintain good practices, I would say give yourself at least that much. So the groups directory as well, again, that's 500 gigabytes of space allocated to each PI and shared between group members. So the location would be /groups/ whatever the PI net ID is. And typically, the way that this works, it is entirely up to the PI how to use it, but typically the way that it works would be that each member of that group would then have a folder that comes after that. So say if Sarah was in my group and she had a folder, it would be /groups/ ejan/ Sarah Willis. That would be her personal folder. And that's typically how it works for each PI and their members. And if you need help creating those directories or managing permissions and changing ownership and things like this, first of all, we'll be covering that later in this presentation. And second of all, if you do need assistance with that, you can contact us at HPC Consult and we'd be happy to help you. Because the permissions can be a little bit tricky sometimes. Okay. And again, for Xdisk, so this is available on request by PI. The first two are available by default. Xdisk is not available by default, but you can submit a request to create one and it should be available pretty much immediately. That 20 terabytes of space is available and shared between group members. The location would be /xdisk/ the PI net ID. And again, reminder that it is a temporary allocation. Expires after 300 days, but then it can be renewed. And all of the regular HPC storage is free. So everything that you see here, this is available without having to incur any financial costs. More info at this link here. So rental storage, as its name implies, is not free. It costs real money. So if you are a PI and you would like to request rental storage, you need to provide a proper billing number and information. So you would request that by going to this page on the portal. So portal.hpc.arizona.edu. That's where all of the storage stuff is managed. Again, not accessible by regular HPC nodes, only accessible by the DTNs or data transfer nodes. And the location would be /rental/ PI net ID. And again, requested by PI with KFS billing number. The data can be copied between the main HPC storage and rental. And the rental storage can be requested at portal. So here's the link. If you have the access to the slides, you can go ahead and click that link to see how to do it. And more info on rental storage is in our documentation. Okay, so RDAS is the next one. So let's go into the details of this. So RDAS, again, is not an HPC file system, but can be copied over. It's not really intended for active computational research data. It's more intended for research groups to manage other types of shared data, whatever that might be. Maybe you have a folder full of papers that you all want to read and you share it here, or something like this. Or maybe you have promotional materials or something like, it's entirely up to the research group what to do. But again, you certainly can store research data there, but it just isn't going to be available to the HPC. So it's just making sure that you understand where it is going to be available and where it's not going to be available. So if additional space is needed, Xdisk and rental are great options. It is managed through the HPC portal and intended for shared desktop storage. So the network drive, again, a network drive rather than a physical drive mounted on personal computers. So this RDOS is, you can think of it sort of like our in-house version of something like a Google Drive. Because it's managed through the portal and you can click and drag and do all those normal types of stuff that you would do on your computer. It does require a U of A IP address in order to access it, meaning that you either need to be connected to the campus connection or through the VPN. So if you want to access RDOS, you either need to be on campus or activate your VPN. And lastly, we have AWS tier 2 storage. Oh, I'm sorry, question.
Just one small thing about RDOS. So does my PI need to request that?
Yes.
Oh.
It does need to be requested. So it can be requested again through going through the portal. So that portal link is back here. So you just go to this same portal link, portal.hpc.arizona.edu. And then if you look at this image, the storage tab at the top points down to create shared desktop storage. And that's what you would click in order to create the RDOS.
So if after spending 1 year, if someone does not pay for the next year, but this data will still be there, but will not be able to access it, or will it delete it?
RDOS is free. So RDOS is not a paid service. Rental is a paid service, and the AWS is a paid service. But beyond that, you don't have to worry about it. But I'm not sure exactly what the policies would be for rental. Say if a PI were to stop paying for rental, would all of that data simply disappear?
No, you might make it read only or
Okay.
something like that, restriction.
They will stop access, but data will be there, might be.
Yeah. I don't think it would be removed.
Okay. So it doesn't sound like the data would be removed. Yeah. Again, good to have backups, right? Just in case. So our last storage option, AWS tier 2. And tier 2 here refers to the purpose of the storage as being for archival rather than for active data. So there are different pricing tiers that are listed here. And the pricing tier depends on the amount of time since the last instance that you downloaded that data, right? So if you put your data on AWS, and if you have more than 1 terabyte, then you start incurring this cost of $23 per terabyte per month. And that will remain for 3 months. Once you have had that storage or that data in storage for 3 months and you have not downloaded it, it will move down to Glacier. And once it has moved there, it moves to a free tier. But at the same time, this implies a restriction as well, where the data is not immediately available for download, but you have to submit a request, and it might take some time to retrieve that data. And once it has been retrieved, it bumps back up to the standard. So every time you download something, that data is moved into the standard tier, right? And then only after a certain amount of time does it start to move down this tier. So there's more details about this. If you want to read more about it, there's information on our docs. And within that documentation page, it also links to the Amazon Web Services own page of information on it. So this is called intelligent tiering, what I'm talking about right now, where the tier of data storage is dependent on how much time it has been since the last time you downloaded it. And there are a number of different caveats and nuances with AWS. So please be sure to read up on all of that information. We don't have time to cover it right now, but please be sure to do your homework on how AWS functions in order to get the most out of it and to see if it actually meets your needs before going ahead with the service. So here are, that was supposed to be an animated thing. Oh, so I guess let's just, are there any questions on anything that we've covered so far? From anybody in the room or in the Zoom?
We have one from the chat. It's asking, can we use HPC for teaching accounts or classes or courses?
I'm not sure exactly what teaching account refers to, but there are certainly usages of the HPC for courses. We have something called class groups. So this is a way to manage access to the HPC for teaching purposes. This gives students access to Ocelote, which is one of our clusters. So it is possible certainly to use the HPC for teaching purposes. Does this answer your question?
Yes.
Okay.
Yes, it does. Thank you.
When you say RDAS and AWS are not connected to the HPC, you mean regularly connected? I mean, obviously there has to way to get data
Sure,
between
yeah.
them.
Sorry, it's a little bit vague language here, right? What I mean is that they're not directly accessible to the compute nodes, right? So it is certainly possible to copy data from one system to another, but they're not directly accessible to the HPC file system.
Have to make a special request.
Yes, exactly. Okay, any other questions before we move on? Okay. So let's talk about file permissions, because this is a big topic when it comes to accessing and managing your files on any type of shared system, including the HPC. So all computer systems have some form of permissions, whether you're aware of them or not. These are especially important on a shared system, so you don't want other users intentionally or accidentally messing with your files. So we're going to talk about the Linux file permission system, because our HPC system runs an operating system called CentOS 7, which is a form of Linux. So we have to think about how Linux manages its file permissions. So if you want to view file permissions for all of the items in your current working directory, you would issue the command ls with the options LHA. And if you want to see file permissions on Open On Demand, you can click this button that says Show Owner Mode within the file management browser. So on the terminal, this is what you might see. So this is an example directory that I have where I've issued this command ls-lha, and you can see there are a handful of different items that show up here. So we're going to go through each of the pieces of information that are available from this output. So on the left-hand side, colored in red, we have the item type. A normal file is indicated by a dash, and a directory is indicated by a D. After that, these are the file permissions that correspond to the owner of the file. So I've color-coded things here. So all of that blue corresponds to that username in blue. So that's my username indicating that I'm the owner of that file or folder, and that the permissions there in blue are the ones that correspond to each of those items. And on the right there, you can see our legend. R refers to reading, W refers to writing, and X refers to execute or running a particular item. So you can see for most of these, I have pretty much full permissions as the owner. And then the next column here is, there's the blue square indicating that that's the owner. And then the group is listed there in orange. So you can see in that column, the second set of 3 characters, there's slightly different permissions that are available. And that group is, in this case, staff. It might be a different group for other items. So all members of that group, so the group contains a certain list of members. That list of members has permissions at the group level that are indicated by the column in orange. So you can see that nobody there has write permissions. So even though a user may be a member of the staff group, they would not be able to modify any of the items in this folder, but they would be able to read or execute a handful of different ones. And then you can see there for folder 1, folder 1, there are 0 permissions available for staff. So it's possible to manage these permissions on a per item basis, and also by each category. And then on the right for the last is other. So that's all other users on the HPC system. So that refers to anybody who is not the owner and not a member of that group. And generally, it's best to keep the permissions in the other category as restricted as possible, just for security. Okay, are there any questions on this? Because this tends to be, you know, there's a lot of information that gets shown with this particular scheme here. So are there any questions regarding this?
So I think this is maybe trivial. I'm just looking at my folders and I noticed that like right after my name is like there are files that has my PI's name, but there are like files with a label students. Does it matter?
So it says student there?
Like for example, you show up, it shows staff,
Uh-huh,
but mine have like some are students, some are the name of my PI.
okay. Those are different groups, right? So student is a group. So if you're a student, you're a member of the student group. Your PI also has a group. So in the case where it's in that second column, even if it is a username, it's referring to that group, not necessarily to that user. Right, so everything in that orange column there, that second column, those are all names of groups. Even if it is the same word as the PI's net ID, it's probable that their net ID and their group are under the same label, right?
So you
But
say
everything in that second column is referring to a group, everything in that first column is referring to a user, right? Does that make sense?
yeah, that makes sense.
Okay.
So does it also means that everybody under the group of students, they can read my file?
So it means everybody in that group has access under that whatever
File.
permissions are listed there.
Okay.
So if it's R, then they can read it.
Okay.
Yeah.
Thank you.
Okay, let's keep moving. So one important thing with this file permission system is oftentimes we get a lot of questions about exceptions to this system, like, oh, can you make this one particular file accessible to this one particular user? And unfortunately, this is the system. There are no other ways of managing file permission. There's no secret backend that any of us have, and no user is in any particular special category. So that effectively means that PIs cannot be given any specialized access that any other user cannot have. All users are treated exactly the same in the Linux file permission system. So whether you're a PI or not, your file permissions functionality is effectively exactly the same. It just depends whether you're the owner, whether it's the group that you manage, right? Those are the only things. So again, the file permission systems treats PIs the same as all other users. So owners can modify permissions of an item using the chmod command. So here's an example of a chmod command. If I have a folder called test, I can use chmod g plus r. So that would add it would add the read permission to the group category. So when thinking about file permissions, it's good to have two items in your head. One is what permission is available, and the other is what category of user is that permission available to. So we have a full guide on our Linux file permissions in our documentation, so follow that link and find more information there. Of course, we're not going to get into every detail of it right now, just trying to give you a general overview. So owners can also change a group association as long as the owner is a member of both groups. So the chgrp or change group command. So yeah, say, you know, if I'm a PI and I have multiple groups and I wanted to make one folder available to one group but not to another group, I could use this chgrp command. And it is important to note that normal users, meaning pretty much everybody, cannot change the ownership of files, even if they are the owner. So owners have access to changing permissions and changing groups, but not to changing the ownership. This requires pseudo level permissions. If you do need to change the ownership of a particular file, you can reach out to us and we can manage that for you. This is not something that needs to happen all the time, but it's just something to be aware of. So that requires pseudo privileges and send your request to us. Okay, so more on file permissions here. And as always, just feel free to post in the chat or raise your hand if you have any questions. So octal permissions are a certain way of representing all the different combinations of permissions that can be applied to a particular folder. So it's a shorthand method. So an example command would be chmod 754 for a particular file. So each of those individual numbers, 7 refers to the combination of permissions for that first category of user, which was the owner, right? Second category of user was group members, and the third category of user was others. So it's always in that same order. So in this case, 7 refers to the permissions for the owner, 5 refers to the permissions for the group, and 4 refers to the permissions for all other users for this particular file. So what we have these 754 here, and we have that octal code reference on the screen. So what permissions do group members have for this file after you execute this command? So what would they be able to do to that file?
So it's read and executable?
Yes, so it would be read and execute. So if you look down at the octal codes, 5 refers to r-x. So that dash indicates that you don't have access to write permissions, but that you do have access to the reading and execute permission. And then looking at the 4 there, so that would be referring to the permissions of other users, right? That 4, if we look at our guide here, that refers to the fact that they can just read that file, right? And then the 7 would be full permissions, read, write, and execute for the owner. So owner gets RWX, group members get RX, and other users get just R. So code's made up by adding values for each option. So if you look over here, 4 refers to just R, 2 refers to just W, and 1 refers to just X. So if you look at 3 there, 1 plus 2 is equal to 3, meaning that you have access to both W and X. So that's how this system works. And it's important to also mention the recursive option, because if you just execute the chmod command on, say, a directory that has a lot of files or folders within it, right? If I just execute chmod on this directory, it's only going to change the top level folder. If I want to change everything inside of that directory, I need to include the recursive option, which is that capital R that comes after chmod, as you can see there on the screen. So that would change all of the items within a specified folder and not just the parent folder. And it's important to note, if this is a folder that contains a very large number of files, a very large number of subdirectories, it can take a very long time to execute this command. Say if you have thousands or millions of files, right, that can take, hours to execute. So it's important to be aware of that. Okay, so on Open On Demand can be used to manage files. It's not possible to modify the file permissions in Open On Demand. So if you want to modify any of those file permissions, you'll have to go onto the terminal and execute those commands that we were talking about. But it is possible to view the file permissions. So if you go on to Open On Demand and you click that Show Owner Mode button, here's an example of what it reveals. And you see under Mode, you have those octal codes that we were talking about. So if you want to know what the particular set of permissions is for a particular file when you're looking at Open On Demand, it's only going to give you these octal codes. So keep this octal code reference handy because, I mean, I personally can't remember it too well off the top of my head. So I usually keep something like this handy. So if we look over here, that first file is 730. So 7 tells me that I have full access for the owner. 3 tells me that I have WX access for the group members, and 0 tells me that I have no permissions for all other users, right? So that's what is indicated there underneath the mode column. Okay. Last thing to talk about for file permissions is the cluster defaults. So what are the default file permissions when you are creating folders and things on the cluster? So as we talked about previously, PIs have shared folders within groups/PI netid or in xdisk/PI netid. And what to do with these spaces is entirely up to the PIs, but generally the recommended method is to have a subfolder for each group member that they each own. So say I have student A, B, C in my group, I would have folders groups/my_username/A/B and /C. And then if I were to look at the owner of each of those folders, it would be that user that owns that folder. This is the typical default way of setting things up. And it's best to have that particular user as the owner so that they can create and modify everything in that folder. They can perform all their work that they need to do rather than have the PI as the owner, which can cause some difficulties for the user if they're trying to do things in there. So if you do need to change, so this can cause a little bit of a problem sometimes if a PI wants to create a new folder for a group member and they go into their groups and they, create that folder, mkdir, whatever the name of the folder is. They might say, oh, well, now I can't change the ownership. It's owned by me because I created it, but I can't change it to this other user. So typically it's best just to ask HPC Consult to help you set up shared files and folders because changing ownership is something that requires elevated permissions. So the default permission setting for such folders is 700. So 7 again is the full set of permissions, and 00 would be no permissions for group members or other users. So, and remember, I just have to always say, even though PIs are the owners of their group's share, the Linux file system goes according to the ownership of that folder. So even though the PI would be in that group, the default for those folders is to not have any access for that. So if you do want to change that, you can either have the owner of that folder perform a chmod command in order to increase the file permissions that are available to group members, or you can come to us and ask us for help in setting up some sort of shared file or folder for your group. So we talked about this, how to see the ownership of a particular folder using the ls-lha command. And we talked about using chmod in order to change those permissions. So those are some example commands there. Okay. So summarizing what we talked about so far, the groups and xdisk are shared spaces. The group members typically own the folders within those spaces. Each member controls the permissions of their own folder. Only HPC Consult can create folders with proper ownership. Remember, changing ownership is something that requires elevated permissions. And if you'd like to set up a shared space, because this task requires changing ownership, you can ask us for help with that. Okay, so that's all of what we have for file permissions. I guess we're getting pretty close to the end of the time here. But I'm just going to keep going because we have a few more things to talk about. So let's talk about transferring data. I'm going to go through this relatively quickly just because there are a lot of different methods and we have in our documentation full instructions on how to use each of these methods. So There are both terminal and graphical methods. On the graphical side, you can use Open On Demand or another service called Globus or CyberDuck. This allows you to transfer data with some type of application interface. On the terminal, there are commands such as SCP, rsync, or rclone. And if you go to this link on the bottom here, you will find full instructions on each of those. And some of the services that we have available do both. Here's a summary of all of them. This is just a screenshot from the documentation. You can find it there. So you can transfer files on Open On Demand by clicking this upload or download button that's available. So Open On Demand does limit data transfers to 64 megabytes for uploads. You have moderately sized transfers, less than 100 gigabytes. You can use our command line options. And for very large transfers over 100 gigabytes or to transfers outside of the university, you can use Globus. So that's the recommended method there. So those are command line utilities, and this is a graphical application. So here's an example of an rsync command. So you type rsync, your options, your path to the local file, and then the path to the HPC. And notice that there is the file exfer node there in order to access the file transfer node when you are performing this copy. And here's a list of the options. So recursive, verbose, and archival. Those are pretty much optional. Recursive, you would just need to include that if you want to include all of the items within a folder. If you're working with a large number of files, it's always or typically best to create an archive in order to bundle files together in order to reduce file counts and to get some compression when you are transferring the data. So this is important when using a large number of files or for very large files. So common archive utilities, you may have seen these before: tar, gzip, zip, or rar. These are just archive utilities that exist. Limit the number of files in a single folder. If you are performing your analysis and you have millions and millions of files, it's best to separate these into a number of different parent folders. If you have too many files in one folder, it can cause problems for the file system. So try to keep your file counts in the thousands rather than in the millions. So we're going to skip that. There is instructions on using Globus in the documentation. I just want to quickly get into software, right? Just because I don't want to use up any more of your limited time. Transfer methods, again, in our documentation, highly recommend reviewing those. And so let's get into software overview. So the availability of software depends on the type of node you are on. So login node has bash commands, some basic system utilities and functions. It has slurm commands. So if you want to submit a job, use SQ to view previous jobs, etc. These commands are all available on the login node. The data transfer node does have some limitations. So if you're looking for certain command or maybe a compiler or something like this, you're not going to find it on the data transfer node because it's not really for that. Compute nodes have available the module commands. So we'll talk about the module system. And it has, that system is used to give you access to the full suite of installed software on the HPC. So the module system, since the HPC is general use, there's tons of different research softwares installed and available on it. You probably don't need most of it. So it wouldn't make sense to have all of the software available to all users at all times. So instead, the HPC uses a system called LMOD to manage users' software environments. When you're using LMOD, you use the module command. This module command is only available on compute nodes. If you try to run the module command on the login node, it's going to say command not found. So if you're trying to load some software and it's not working, double check the type of node that you're on. You cannot use the module command on the login nodes, gatekeeper, DTMs. Modules are pre-installed software packages that can be loaded. So, while there are hundreds of modules, not all software that can be used on HPC needs to be a module. So users can download and install packages for Python, R, etc., as well as compile programs from source in their own personal directories. So modules are generally software that is either widely used by a lot of users on the HPC, or something that is maybe a little bit too complex to install in a personal directory, or maybe needs to be linked in some particular way to other software. So there is some blurriness in terms of which software should be used as a module versus which software should be used personally. If you have a question about any of that, you can just let us know, and we'd be happy to provide you some guidance on that. So the module commands, we can review the different types of module commands. When you're on a compute node, the module commands are available. So the usage would be module, the type of command, and then any arguments that need to come after it. So here are the different options. So if I type module avail, if I provide nothing after it, it will print a list of all installed software. If I do provide a search term, then it will print all matches to that search term. Module load will add that software to your environment. So if I want Python, I would do module load Python, and then it makes Python available, or R, or console, or whatever it is. Unload would, of course, do the reverse. So it would remove that from your path. So if there's maybe some type of software conflict, if you have two different versions of something and you want to get rid of one, you would use module unload, and that would get rid of it. Or you can swap them with the swap command, and this just removes the first one and adds the second one. If you want some more information on that module, you can use the module show command, and this will show you what directories have been added there. And then once you have those directories, you can go look inside of them to see what sorts of options and files and libraries and things are provided with that module. Same thing for Spider. It's just another tool to manage module information. And the module list command is one that will list all of the loaded modules. So if I've been loading and unloading modules and I don't want to remind myself which ones I have available in my path currently, I would just say module list, and that prints out all of my currently loaded modules. Okay. So if you're working on the HPC and you're thinking, I need whatever software, how do I get it on there? So the first thing to do is check if it's already available as a module. It might be possible that it's something that somebody has needed in the past and that it's already installed on the system. If it is not available as a module, check if it's part of a package management system. Something like Python or R has their own package management system, and you are encouraged to use this package management system. So if you're using Python, it might be something like the Python package index, PyPI, or Conda, or Mamba. There are different ones available. If you're using R, there's the CRAN repository. There's also the Bio R, can't remember what it's called, but that's also another package management system for R. These packages can be installed by users in their own directories, and we have instructions on how to do that in our documentation. So this would be the link for Python, and if you go there, you'll also see information for R and other types of common software. So if it's not part of a package management system and it's not available as a module, it might be possible for you to download and compile it locally. So if you have a GitHub link and you want to download and install that software, you certainly can do so. You would just need to specify your own personal directories rather than system directories. So if all of these fail, and if the software is compatible, and if there is sufficient use planned for the module, then we will install it as a system module. We'll be happy to do that for you. So this is pretty common, just, you know, if we just ask that you check these options first before asking us to install it as a system module. But if it meets the requirements, we are more than happy to help you get that software set up on the HPC for you. So just shoot us a message and we'd be happy to help you. Installing personal software, we're getting very close to the end here, so thank you for bearing with me. So users cannot install system modules. You can download and install software in the directories that you own. So we talked about previously how you have your home directory, groups directories, your X disk directories. Software can be installed to those locations. If you do intend to compile software, that should be done with a compute node. Compiling is a task that can be very CPU intensive, so we ask that you don't do that on the login node, but instead do it on a compute node in order to avoid straining the system. So yes, again, don't compile software on the login node. So here's the general formula for how to do this. So I'll give you some commands here. So the first step would be to download and unpack the software. So here we see the prompt on the left-hand side, user at CPU 39 in the folder called make example. And what I'm doing here is I'm issuing the wget command to download the GNU Hello program from that link. Once I've downloaded it, I would extract it with this command. So the tar is the archive utility. This would expand that folder. And then I would change my directory to move into that folder. Next, I would configure the software. So in this step, what I'm doing is configuring it to be installed in my home directory. So you see there, it says $home. That's an environment variable that refers to my home directory. So if I did not do this, the default might be to try to install it in the system directory, and you would get an error because you don't have permissions to access those system directories. So this configuration step is important to point it to the folder that you own in order to install it there. And then the third step would be to compile or install it. This would be done by issuing the make command and then make install if necessary, and then modify your environment. So I've installed it to a particular directory. You see here, I'm adding the same path that I had in my prefix into my path. And what that does is simply make everything inside of that folder available and any system location. So I could be in my X disk, I could be wherever, and I would still have those executables available without having to point to the full path. So this is the general roadmap for compiling personal software on the HPC. That configuration step there is potentially one of the more important ones, so be aware of that. And so we've talked a little bit about Python and R, Anaconda, etc. So we will get more into software later on. We'll have a whole workshop on this that'll be taught by our other consultant named Soham. He'll be doing that on October 18th. So keep an eye out for that if you are interested in diving into further detail on software and environments. But for now, next week we'll be meeting in Weaver 212. So it won't be in this same room that we're in currently. It will be over there. And we'll take a detailed look at running jobs on the HPC. So this is a big topic. If you missed any of our previous ones, I definitely recommend reviewing those materials before coming to the running jobs workshop, because it will be sort of dependent on the things that we've talked about so far. But that's a big one. So this is, running jobs is how you do your work on the HPC. So please join us for that session as well. And with that, here's some information and we're done. Thank you for listening. If you have any questions, feel free to turn on your mic and ask them or type them in the chat.
There's a question, is there an easy way to wipe the home storage, remove all hidden files and environments as well?
That's a good question. Easy way. I think the best thing to do would probably be to ask us to do something like that, just to avoid removing anything potentially important. It's just good to know which of the files you need to remove. I would recommend against completely wiping everything, but if you do need to reset your home directory for some reason, yeah, you can just ask us.
Thank you.
Thank you.
This yesterday, overriding his path statement, something. I can't do LS anymore. Maybe you can.
All right, thanks, everybody. If you do think of a question later on, you can see here, there's a link to the HPC consult request page. That's a link to our ServiceNow page. If anything comes up, feel free to submit a request there, or you can drop by our office hours on Wednesdays and view the full schedule of our workshops at the link at the top. So thank you very much for attending, and we'll see you next time.